Like this one. Okay. I can click and close this one too. As I said before, I'm not familiar with Zoom, so I will get some difficulties about this, but if you see the screen, it's okay.
Your screen is visible, but it's not full screen yet. Okay, now it is full screen.
Now it's full screen. I cannot use the application sharing because I will use a demo. I will share a demo, so I could only share my screen.
Okay.
I will start whenever you say so.
Yeah, you can start if you are ready.
Okay. Today I will talk about what a RAG is, and it will be simple. It will not be a technical presentation. It will be simply what a RAG is, what is it is used for, or how can I use it. I will show a simple demo, and I will open a GitHub repo, public GitHub repo for it to replicate the results. So before introducing myself, what will I talk about today? I can summarize it. First, I will talk about LLMs and what the LLMs are, or why are we using LLMs, why are not we using transformers anymore, and what small language models are or large language models are. And then I will tell something about what the RAG is and why are we using or why are we needing it. Then I will exemplify a RAG structure, but it will be a simple one, as I said before, and I will show a demo. I am working at Trakya University. For the 4 or 5 years, I am working on AI, I am working on NLP, I am working on vision transformers, vision language models. I have tried a lot of things. Some of them maybe I am not expert about, but I can easily say I worked a lot on NLP, so I have my knowledge about LLMs or embeddings or etc. So if you want to contact me, you can find my mail or address on my university profile. You can find my GitHub repo. A lot of my repositories are private, but if you want to see some code or examples, or I can help you with something like, I don't know, LLMs, transformers, training models, or testing models, you can contact me any time you want. So I will start with LLMs. Why do we call that LLMs? Because these are language models and they are large. They are larger than RNNs, LSTMs, CNNs, or I don't know, transformers. They are starting from 1 billion parameters to 100 billions or more. They are memory dependent. You cannot easily train an LLM on your local machine. You need a lot of RAM. You need a lot of GPU power. But there are some operations you can use bits and bytes or quantization to use to easily train some parameters of it. Not all the parameters of LLMs, but the subparts of LLMs to make your job to get your results or specified results. These are open source. You can use Llama, you can use Mistral, you can use Phi. Phi is a small language model, but you can use them too, or Gemma. You can get them from Hugging Face, I will talk about later. So you can easily, but if you have memory, you can easily train them with your own data and you can make them work with your specific data. For example, I have trained a data on text readability. I have trained an LLM about steganography. I have trained and vision transformer to use in dental processes, detecting some dental problems. So you can use the language models or visual language models or large language models on your specific task if you have enough data or if you have enough memory. And you can easily get some answers to questions, but if you use generalized LLMs, they cannot help you with the specified questions as general questions. So to try LLMs, you can use online LLMs like known with everybody, like ChatGPT, Gemini, Find. You can use them with premium features, or you can use the free versions of them. But if you want to use the LLMs on your machine locally and with a little tuning, you can use them as a for a specific tasks. You can get them from Hugging Face. You can use a tool like LM Studio. It's easier than Hugging Face because in Hugging Face you should download the model, write some Python code, not a long code, but you need to know some Python skills. But in LM Studio, you can easily download a model and start chatting with it. Or there's a open source project named Olama. If you use Olama, it provides you a lot of models too, and these are free too. These are in English, by the way. They are not multilingual mostly. But if you want to use it in Turkish or another language, you have to fine-tune them. And I won't show you how a fine-tuning operation is carried on today, but if you want to have a knowledge or I don't know, a tutorial about it, you can write me and I will provide a code snippet for you. To give an example for my easy RAG project, I will use Olama today. It's free, you can download it, and you can download models or models in Olama in terminal, or it gives you some graphical user interface in web. You can use it and run it to locally run your models. But as I said before, it needs if you're using a lot of LLMs with a lot of parameters like, I don't know, 70 billion or 7 billion parameters, you will need a lot of RAM. And I can say that if you have running it on a Windows machine or Linux machine and you are using a GPU, you have to have a lot of VRAM than standard RAM. In Mac, these are the same. The SoC chip can use the RAM in your it can use it like GPU memory, your system memory. So you can use easily on Mac these. And it can be used with LangChain. I will tell about the LangChain or what the LangChain is. So my presentation, yes. A RAG is, what does RAG mean? RAG is Retrieval Augmented Generation. It means that you can ask LLMs some questions and LLMs can help you with these questions and they are answering your questions, but LLMs are trained with generalized data. It won't be trained on your specific, I don't know, academic project or your specific info. For example, if I ask who is Emir Öztürk on ChatGPT or I don't know, Gemini, it will say, I don't know, I have found in web, etc. So LLMs cannot answer all these questions. So how can we make LLMs answer these questions? We can fine-tune them. But as I mentioned before, if I want to fine-tune an LLM, I need a lot of RAM. I need a lot of VRAM if I use GPUs. I need a lot of data to train the LLMs. Since they are big models, I cannot give them, I don't know, 100 of vectors and learn the data. I cannot do it. I need millions of data, millions of sentences, millions of lines, I don't know. So, and most valuable of these are I need a lot of time. For example, for a project like fake news detection, I have tried a model. I have tried to fine-tune a model that contains, I don't know, maybe 60,000 lines. A data set with 60,000 lines. I have to train a Llama 2 model, not Llama 3 or Llama 301. I don't remember my graphics card, but I needed 23 or 24 hours of training just to see if it can detect the fake or real news. So I need a lot of time, and as the data set or as the fine-tuning process is getting larger and larger, you had to have a lot of time. And as previous speaker mentioned before, Dr. Işıl Berkün mentioned before, these are progressing too fast. You cannot fine-tune an LLM constantly. You cannot fine-tune an LLM if you have new data every time. So we need a mechanism that have to get new data constantly and somehow train that data or transform the data into what LLM understands and told the LLM like, I have that data and use that data and answer me. You should say something like that. You should have make something like that. So information is updated frequently, and we have to train the LLM, and we don't do it because we don't have enough time to train the LLM. I am seeing a hand. Will I take the questions?
Yeah, later I will ask.
Okay, later. Okay. And as I mentioned before, sources must be upgraded quickly, and LLMs must understand it easily. So what we'll use here is embedding. If you work to train LLMs or not LLMs, train some deep learning models, even RNNs and LSTMs, you can see if you are using text and if you are running NLP projects, you need to learn embeddings. Embeddings are the numerical representation of text data. We have to convert the data into vectors or numerical values to train LLMs or train models and get the results. And whenever I ask a question to an LLM, if I write the code, not use the ChatGPT or a similar system, I have to first tokenize the sentence and get the embeddings for this sentence and predict the values. Then I have to decode the result embedding vector into natural language again. So I have to use embeddings. And if I have data and if I need persistent data, what I mean is maybe I want to teach LLM some new info and I want them to be stored in a database, and later if I ask the same question, I want to get the same answer. So I have to store them somewhere. So I can use classical DB or I can use a vector DB, and these are popular too. The vector DBs are. And the vector DB is something like that. It's almost a key value store, but it has some indexing features, or it has some similarity measurements on embedded vectors. For example, if you use Manhattan distance or Euclidean distance on some vectors, you can easily get results on these vector DBs. And some traditional DBs can give the same opportunities as vector DBs, and I didn't have a time to try these, but they say Elasticsearch has some vector similarity search feature, and it is working as fast as, I don't know, Chroma or Vivid or Face. Face is a memory database, but it can easily it's easily comparable with some known vector DBs. And MySQL and PostgreSQL can give some vector DB features too, but as I said before, I have used Chroma or I have used V8, but I didn't have time to try traditional databases vector search operations. So I am using Chroma as an example today for my demo, and they're looking for similarities to take the documents about my question and give them to LLMs. Chroma is an vector DB, as I said before, and it can be used easily with Python. And as I said before, it's a key value store like working DB, so I can easily query it with, get me some similar documents about the embedding vector I gave to you, and it gives similar n vectors to you. You can specify the n value. You can select 3 or 5 or 10 as you want. And it is working on device like Llama or like other vector DBs. You don't have to register somewhere or pay something. It's open source for personal use. And as a parenthesis, you can use them in memory or persistent, but if you use them in memory, you will lose your data after closing your application. So I recommend using the persistent one. How can we use RAG, or what do we have in RAG systems? Actually, in RAG systems, you don't fine-tune LLMs, and you didn't teach LLM some new data. LLMs are used for just summarizing the data or use a data that you have to look about. For example, for my previous example, if I ask who is Emir Öztürk to an LLM, it cannot answer to me, and I will show in the demo who is Emir Öztürk, and it will not answer to me. It will say, sorry, I cannot find anything about him. So what we need is, first, we need some documents about what we will ask for, and we have to convert these documents into pages and chunks, and after that we have to use them as embeddings. We have to convert them into embeddings, and we will store them in a vector DB. For our example, it will be Chroma. Then, whenever we want to ask a question about our documents to LLM, we will first query the database, ask our question, and we will convert our questions into embedding too. Then we will make a similarity search on our DB, vector DB, and this vector DB will return some results, for example, 3 results or 5 results, whatever you want them. And I will get these results, get these documents, and both my question and the results came from the vector DB will feed into LLM. And we will ask to LLM, use these documents, use this info, and get my question. And for my question, give results from the documents that I gave you. So LLMs are just summarizer for this project. And LLM will get a result and return the result to you. To use a mechanism like this, there are tools, of course, and these tools are very easy to write and very short codes to write. It's not like training the data or manipulating the data to prepare it for training. So we can use easily in 3 or 4 lines long chain methods, and we can easily use an Olama model to use it free. Of course, you can use it with ChatGPT, you can use it with Mistral, or you can use it with paid models, but you have to have an authentication token for using these. But if you want to use the open source one, you don't need any authorization process. So to use LLMs, we have to use Ollama for language model. We use ChromaDB or a vector DB to store embed vectors, and we have LangChain to connect them, communicate with vector DB and communicate with LLMs. It can be used in Python and JavaScript, but I recommend Python. And I can easily say, if you are developing an AI project, it can be whether training or using it. Python is 99% must be your first choice. And as I said before, if you use open source LLM models, open source embeddings, and open source vector DBs, you can use them all free and all locally with ease. Another thing to mention is processing PDFs, and processing PDFs is the most problematic part of this project, not the using LLM part, not using vector DB part, but processing the PDF part, because PDF is easy to parse, but easy to get errors while parsing. So as I will show you in my demo, I will get some problems with chunks, and I will not try to solve it, but it will always be some sort of problem about reading PDFs or its formats. But it's like using Llama, like using Ollama or LangChain. There's a tool in LangChain that parses PDFs and chunks them, and we can use it with ease too. And we must read PDFs as text, then split this text into some size of chunks. Then we have to convert these chunks into embed vectors and store them in DB. And I will use a code snippet for it, and I will show it to you in demo. Then we have a prompt template to give to the LLM, and the template must contain something like, I have these documents and use this document only. It's for, how can I say it? If I don't write this template on these, for example, as I see in the screen, answer the question using only on the given context. If I don't give it to LLM can use the context and use its own data, and its own data must not be producible or usable by me. So I need to use what I gave it to the LLM. So I need to specify that please use only my content. And as you see from the blue line context, I will give the chunks embed vectors returned from DB in the context one. Then I will give my question to LLM in the same prompt, saying answer the question based on above context or given context. What you write here is not so precise. You can use above, you can use given context, or you can only use this. LLM can understand that and return the result to you. This is not a strictly typed prompt template. You can easily change it, but the sample I give in the presentation works beautifully. So as I will show them in demo, I will not give more detail about it, but I can give some advantages about RAC. First, I have been free on training LLMs, and as I said before, it's a hard process. It's time-consuming process. So not being fine-tuning or not need to fine-tune an LLM is a bless. So it's a clear advantage of RAG, and you can easily upgrade the data. You can easily create embed vectors about your specific data and store them in DB, and you have no change in LLM, and you can easily, in 5 or 10 minutes, you can easily get an LLM that can give answers about your questions. And you can use them with different databases. You can use MySQL, you can use PostgreSQL, or you can use ChromaDB, any vector DB you want. You can store your vectors in text files also if you want, but I don't recommend it too. Or you can use any LLM you want. For example, in a project to use with RAG, I have to train an LLM to understand Turkish first. I have trained in Turkish instruction data, and I used the Turkish version of the big, or I don't know, large language model to use or get answers about my question. And it's an ongoing project, and I can say uh, this part of it only. So you can use, for example, you can train an LLM about, I don't know, electrical engineering. You can train an LLM about mechanical engineering, train an LLM about dental processes. And after that, you can use this LLM and your documents in RAG to get your answers about your questions. But I have some disadvantages too. First of all, it's a slow process to split into chunks, and not so slow like fine-tuning LLM, but it's slow. It's also slow, not too bad like fine-tuning an LLM, but it's all still slow process. And there is some chunking problems about keeping the context. If you use chunking and these chunks are not related with other chunks or other embedding vectors, you can see some continuity issues, like it can show the same document as different two documents, and it will be a problem. There is some solutions to that, AutoRex, GraphRex, but it's not the topic of this introduction to RAG presentation. So it has some I don't know, I cannot find the correct word for it, but solutions, but it will be not available today. And the results you see for your questions depends on the similarity measurements of the vector database. What does it mean? It means that if your database can't find a similar result for your question in their embeddings, it will not give the embeddings to you. And you cannot give the embeddings to LLM, so you cannot take the results from these embeddings. It's highly database dependent, and you should select the correct similarity measurement, or you should have to develop some algorithm to handle the similarity measurements, not the vanilla ones. So as an example, I don't know if I see my screen or not, but I will show some code here. It will be short. I will not make it long, but I have two Python files, one for querying data and one for updating the database. And I have to remove the Chroma database I tried before. So I have some querying logic in here. The prompt template in the slide is here, and I have a main function, a path for database, and an embedding function. I am using Olama embeddings, which is, as I said before, free. And I have Olama installed, by the way. If you don't install the Olama tool, you cannot use these running, and I can show it first. I need a terminal for it. If I use all llama lists, I have two models installed on my machine, and I have llama 301, and it has 7 billion parameters. I think it's 4.7 gigabytes. If I want to download a bigger model, I can easily search for it in Ollama's site. And for example, I can select some models from 302 is here. For example, I need a bigger model. I can select 7 billion or 405 billion model, but it's larger, and it can't be run on my machine too. So if I want to run it or if I want to download it, I can copy it from here, go to the terminal right here, but I have already installed Llama 3 on my machine, so it will not do anything for me, so I won't press enter. So whenever I use it, I can easily use it from the Python, and what I do here is creating a ChromaDB embedded persistent and check some results about my input query. And if I find some results, I can use it for my model. And since I have no database installed, I can try with the question I give, who is Emir Öztürk? I made a typo. It will say, sorry, you can't find the result to me because Llama 3 model don't know a thing about me, so I can't get a result. So how can I get a result about me without fine-tuning the Llama model? So what I need is to obtain some documents about me and split them into chunks and save it into a vector DB to use in query data script. So I have three methods here. One method for getting documents from local storage. Second method to save into Chroma. I won't get into the details. And a third method for splitting the text and obtaining the chunks. I have some PDFs about me here. For example, I have a lecture content for my C# lecture, I think, yes. ChatGPT prompt for me without consisting 3 paragraphs, and a PDF about me taken from the Trakya University site. I have 3 PDFs, and it's here on my desktop, and my script is here. Now I will get the PDFs, then split them into chunks, read the text, and convert them into embeddings using Llama 3.1 embeddings, all Llama embeddings, and I will add the documents into database, and I will see some files updated here, and I can easily delete that and try it too. Whenever I run the scripts, as I said before, I'm getting some wrong positioning, wrong pointing object. It's PDF issues, by the way, and for 3 PDFs, it takes about 3 or 4 seconds, or maybe 10 seconds, I don't know. But if you have more PDFs, more pages, if you have more data to show to the DB, you have to wait a little more. So I have created my DB now, and I have some data info about me from now on. So from now on, I will get some results, and I will get 3 results for my example, and I have time, I can try the 5th one. And can I take it here? Yes. Now, if I run this script and ask about me, who is Emir Öztürk, it will query the DB for similarities and takes 3 maximum documents, and I will give the LLM Llama 3 these are my context from DB, and this is my question, who is Emir Öztürk? Give me an answer, and it will give me a response. These are some formatting codes like for readability, and it will say, based on the given context, Emir Öztürk appears to be an employee of Trakya University. It detects that I work in Trakya University from the text, but it cannot detect I am a lecturer there, but it's found the evidence in if my mail address as evidenced by his email address, blah, blah, blah. So with a 10-second process with 3 PDFs, my LLM can respond to my questions, my specified questions. But if I try to fine-tune the LLM for learning me, I should have need more time, I think. And you can use this for every text data. Also, you can use with visual data. You can extract images from PDF and learn, get them to learn with LLMs, but there is a little nuance for it. You have to use a vision language model to interpret the visual or image results. I can easily take the Python for the end of my presentation. And if I try to ask the question, now it says faculty member because the previous example, it can't access the PDF. It can access PDF about me, but it can't access the third PDF. It doesn't use the third PDF. I mentioned it before. If your DB doesn't return you a similar vector, it has three PDFs about me, but it only returns 2 of it. So the LLM can respond using these 2 PDFs, not the 3 ones. So as I said before, you need to select your similarity measurements carefully. I don't have time, I think, but I have time for questions. If you have some questions, I can take them. And if I
Thank you
see
for
that,
your great presentation. So if anyone has
thank you.
questions, we have a couple of minutes for the questions. If not, maybe I can ask my question. I can start it. So I am also working with LLM models recently. I'm using the OpenAI API. So for now, in my case, it can understand that my documents, probably there is some data already trained on the model. But if I need to fine tune the model, do I only have a single option? Should I use the vector DBs, or there are, or do I have an option to fine tune the model as well? Or if there are 2 options, how should I choose which one?
First of all, I don't think you can fine-tune the OpenAI model if they don't give you an open source option. But
For another
for an
model.
LLM, fine-tuning and vector DBs are 2 separate options. Vector DBs are only storing for embeddings. If you want to fine-tune, you can easily prepare your data, pre-process your data as your LLM can understand it and fine-tune it and use the LLM. But if you have some constant data not changing so frequently and you will use the LLM lots of times, I can propose the fine-tuning option. But if you have a lot of changing data, constantly updating data, then fine-tuning is not a good option for me.
Yeah. Okay, thank you.
I have a question in chat, but who paper recommendation for REC and vector DBs? I can share them, but can you mail me about this question? I have to find them and of course, okay, thank you.
Okay. Okay, we have a couple of minutes for the break. So you can leave that breakout room and join the main room to see the next sessions, so that you can join the next presentation you want to join. So yeah, thank you for presentation. Yeah,
Thank you for joining me on this presentation.
yeah, so much.